All right, our next topic deals with nuclear particles. We're going to get into the nuclear physics and kind of nuclear chemistry as well. And basically what we're looking at here are the subatomic particles beyond proton, neutron, electron, although we do talk about that. We also talk about the bulkier particles, the elements with their different isotopes, and how they become unstable. Now, radioactivity is the result of an unstable nucleus. Now, there's a certain ratio of neutrons to protons, or total mass, atomic mass to protons, that is kind of a not exactly a definite number, but a very small range. And when you get either short of it or above that ratio, the nucleus becomes unstable and wants to get rid of something or absorb something in order to make it more stable. Those are called radioactive reactions or nuclear reactions. Now, the nuclear part is, of course, exactly that. It's part of the nucleus. So things are happening in the nucleus that makes this happen. So it's all about instability and creating stability from it. And we're just going to touch on a couple of topics in this, and then get more detailed information if you were to take a larger class of this in college, where it's able to get into more detail. So we're going to take a look at the fundamental products any minute now. There we go. Not fundamental particles, not fundamental products. Fundamental particles that you're going to be seeing in the problems that you're going to be dealing with. Okay, so we'll start off with the most basic one, and that is the alpha particle. This is the biggest of the nuclear particles. There are technically 4 nuclear particles that are being either kicked out or absorbed, depending on what's going on with it, that makes the nucleus more stable. The alpha particle, and this is the Greek letter alpha, is actually a nucleus of helium. Now, helium normally has 2 protons, 2 neutrons, and 2 electrons. When I say helium, I'm talking about helium-4. Now, there's helium-3 and there's helium-5. Helium-4 is the stable one. Now, an atom will have this, but since we are looking at the nucleus, we're going to have 2 protons and 2 neutrons. And so technically, this is a positive ion, but we don't consider it that way because of the fact that it's coming out of the nucleus. We just simply say it's an alpha particle. But the symbol for that is Ag42, and the generic symbol is the Greek letter alpha. The next one tends to be a bit confusing for people, but this is the Greek letter beta, so this is a beta particle. This is the size of an electron, but it's not an electron. It just fits all the categories of being an electron. But in fact, one of the symbols we have for it is B negative, because it does have a negative charge, and you also see E negative for it. But it is essentially not an electron, seeing how it comes out of the nucleus, and there are no electrons in the nucleus. It's just particles the size of an electron that comes out of the nucleus. And the next one is the counterpart to this, which is B positive, and this is called a positron. Positron or positron particles, B positive, and I suppose it could have a symbol of E positive. I'm trying to remember seeing it. I don't remember, but I'm not really, this is not a topic I spent a whole lot of time on. But we're going to be using the symbol beta positive for that. And the last one is gamma, which is the 3rd letter in the Greek alphabet. Alpha, beta, gamma. Gamma is their C. The gamma particle has no protons and no neutrons and no electrons. It's just an electromagnetic radiation. If you recall from the wave chapter, the electromagnetic waves, the most powerful electromagnetic waves are the gamma waves. Waves and when you get into high energy, you have what we call a duality, a wave-particle duality, where they act like gamma rays as a particle or gamma waves as a radiation wave. This is extremely high energy. This is the particle in space that scientists worry about space travel for astronauts. This is why the suits that the astronauts wear is made of lead, because of the gamma radiation throughout space. If it hits a human being, it can be deadly. They burn up the human cells pretty badly. All right, so these are nuclear particles. Then we have what we call bombardment particles. And the bombardment particles are not normally particles that you find being removed from a nucleus. Rather, they literally take like these little guns and they shoot particles at these at an array of atoms or of the nucleus of the atoms, and try to get the nuclei to absorb the particles that are being taken at them. It makes them really unstable, and they break apart into two parts or stay as one, and are just maybe stabilized when you have an unstable nucleus to begin with. But generally you get two particles off it. So let's take a look at some of those. The first one is the nucleus. The neutron. Found in the nucleus, but you can get separate neutrons being bombarded. The symbol for that is 1, 0. It has a mass of 1, but it does not increase the atomic number at all. Remember, the top number is the atomic mass, and the bottom number is the atomic number, which is the number of protons. Okay? All right, so that's the neutron, and they'll bombard it and it'll absorb it, and it does what it does after that. Another one is the proton, which has the symbol of H11. A hydrogen 1 isotope has 1 proton, 0 neutrons, and it will have 1 electron as an atom, but as a nucleus, this is all you have. So this is also considered a proton. We'll often use the symbol P for that in non-equational form, which you'll see in just a little bit. So the next one is deuterium. Deuterium is a radioactive form of hydrogen that has a neutron in it. So the isotope number is hydrogen 2. And like I said, 1 proton, 1 neutron, and we use the letter G to represent that in a non-equational form. We use this in the equation, and we'll explain why in just a little bit. And then the last one is tritium, which is the name for hydrogen 3, which of course means it has 2 protons and 1 neutron within the nucleus, and then the symbol for that is T. Clever symbol.